Welcome to this lesson on primitive type arrays in Kotlin. In this video, you'll learn about specialized array types designed specifically for storing primitive values. These arrays offer significant performance benefits over their boxed counterparts, making them essential for efficient Kotlin programming. Let's understand why primitive type arrays exist. When you use array of int, Kotlin stores boxed integer objects. Each element is wrapped in an object, which adds memory overhead and reduces performance. In contrast, IntArray stores raw int primitives directly in memory. This means no boxing, no wrapper objects, and significantly better performance. The difference becomes noticeable when working with large datasets or performance-critical applications. Kotlin provides 8 specialized primitive array types. IntArray stores integer values. DoubleArray stores double precision floating point values. FloatArray stores single precision floating point values. LongArray stores long integer values. ShortArray stores short integer values. ByteArray stores byte values. BooleanArray stores true or false values. And CharArray stores character values. Each type is optimized for its specific primitive data type, ensuring maximum efficiency. There are 3 common ways to create primitive arrays. First, you can create a fixed-size array with default values. For example, IntArray of 5 creates an array of 5 integers, all initialized to 0. Second, you can create an array with initial values using the IntArray function, passing the values as arguments like 10, 20, 30, 40. Third, you can use lambda initialization. IntArray of 5 with a lambda that returns at times, it creates an array where each element is its index squared. So you get 0, 1, 4, 9, and 16. Accessing and modifying primitive array elements is straightforward. You can read an element using square bracket notation with the index. For example, numbers at index 0 returns the first element, which is 10. To update an element, simply assign a new value using the same notation. Numbers at index 2 equals 100 changes the third element to 100. You can get the array size using the size property, which returns 5 in this case. Primitive arrays support many useful operations. You can iterate through all elements using a for loop. The for num and numbers syntax lets you access each element sequentially. Kotlin also provides convenient aggregate functions. The sum function calculates the total of all elements. In this example, the array contains 5, 2, 8, 1, and 9, so the sum returns 25. Other common functions include average, max, min, and count. Sometimes you need to convert between primitive and boxed arrays. The toTypedArray function converts a primitive array like IntArray into a boxed array of int. This is useful when you need to work with generic collections or APIs that expect box types. To convert back, use toIntArray on a boxed array. You can also convert primitive arrays to lists using the toList function, which creates an immutable list containing all array elements. These conversions make it easy to switch between different collection types as needed. Let's recap what you've learned. First, primitive arrays avoid boxing overhead, providing better performance and lower memory usage. Second, use specialized types like IntArray and DoubleArray when working with primitive values instead of generic array types. Third, converting between primitive and boxed arrays is easy with functions like toTypedArray and toIntArray. Finally, primitive arrays support all standard operations you'd expect, including sum, max, filter, and map. Understanding primitive arrays helps you write more efficient Kotlin code, especially when dealing with numerical data or performance-sensitive operations.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.